5-Minute Mystery by the DSVK family. Taking a closer look at the vowels within the alphabet reveals they are far from random. While A equals 1, E equals 5, and I equals 9 follow the growth pattern of 1, 2, and 3, O equals 15, and U equals 21 create a more complex and interesting pattern. Do you see it? 9, 15, and 21 are the first three odd values that are not prime. These odd values are exalted. That's an interesting word, exalted. It means placed at a high or powerful level. And for an oddball to move beyond prime, it must be supported by prime. This is how the exalted values are built. Let's start with 0 through 29 to better understand the exalted values. We say they are built on prime values, so what is a prime value? Well, a prime is truly odd, supported by 1 and itself alone. Now, supporting yourself and having the support of 1 is foundational for every value that has ever existed. It's called the identity property. So whether the value is even or odd, it can always count on 1 and itself for support. So why are even values so different from odd values? Even values are supported by 1 and themselves, but they're also supported by 2 and one other value. In a sense, 2 fulfills both requirements with the same singular pair. While this is a clever maneuver on behalf of 2, it doesn't yield the same double support intended for even values. Sometimes that's the cost of being clever and taking a shortcut. For the rest of the even values, they have 2 unique pairs supporting them. This makes them all true reflections. However, because the odd values are not supported by 2, they lose out on this extra support that comes along with being a reflection. So instead, odd values that acquire additional support pairs are considered exalted. It almost seems like reflections have it easier. No wonder there are so many of them. 2 may not have had the support it needed, but it was reborn in every single even value afterward to give them all support. That's awesome. And yet, reflections can also reach exaltation through the process of growth. Remember, 4 is exalted in 15. All values, even and odd, can reach the state of exaltation. Infinity is kind of encouraging that way. Some might even say infinity has very high hopes. So this means that all exalted numbers are odd values that somehow manage to get the support of other odd values? That's right. And not just any odd values, primes. 9, 15, and 21 have their identity supporting them as well as another supporting pair. See how 9 gets the support of 3 and 3? 15 finds support in 3 and 5, and 21 stands on the support of 3 and 7. But wait, 21 isn't the last exalted prime in this set. There are 2 more values, 25 and 27. 25 is aided by 5 and 5, a perfect square just like 9. But 27 is far more interesting still. At first glance, it appears to be supported by 3 and 9. However, 9 is not a prime. Therefore, it must be displayed as 3 and 3. This means that 27 has the most advanced support system thus far in the values. 2 identical supports produce a square. 3 identical supports produce a cube. When these identical supports stand alone, we call it perfect. 25 is a perfect square, but 50 contains a square and a 2. 27 is a perfect cube, but 54 contains a cube and a 2. Returning to the letters, 25 equals Y, which is the last vowel in the alphabet. If there was a letter after Z, it would be the 7th vowel in the alphabet, and represent 27. Maybe this is a good time to welcome Omega back into the flock. It was pretty cold of us to kick out such a lucky horseshoe.